Do you think artificial intelligence can think about anything, solve any problem, process any idea, no matter how complex? Most people think so. They see these gigantic models, these systems that write poems, make art, that seem to understand everything, and they assume there is no limit, that it's just a matter of adding more computational power, more data, more parameters. But there is a limit, a fundamental limit. And it's not what you think. It's not memory. It's not processing speed. It's not the amount of training data. It's something much deeper, much stranger. It's something Richard Feynman had already foreseen decades before modern AI even existed. And when you truly understand what he discovered, it completely changes your perspective on what intelligence really means. Let me start with something that seems to have nothing to do with AI. Let's talk about compression. Imagine you have a text file. Say, an entire book. You want to compress that file, make it smaller. How do you do it? You look for patterns. You look for repetitions. If the word "the" appears 1,000 times, you don't need to store "the" 1,000 times. You can create a shorter code that means "the" and use that code instead. The more patterns you find, the more you compress. A completely random file with no patterns cannot be compressed. It's already at its minimum size. But a file with structure, with regularity, with patterns, can be squeezed dramatically. Now here's the interesting part. What is understanding? When you understand something, you are compressing. You're taking a bunch of seemingly unrelated facts and finding the underlying pattern. Newton didn't memorize how every object falls. He found a law, F, due mxa, that compresses infinite individual cases into a single simple equation. Einstein didn't memorize how light behaves in every possible situation. He found E Chasta mc2, one equation, a massive compression of reality. Understanding is compression. It's finding the smallest possible description that captures all the data. And here's where Feynman comes in. He realized something crucial about physics, but which applies to everything, including AI. He realized there is a limit to how much you can compress, an absolute, fundamental limit that cannot be overcome. This limit is called Kolmogorov complexity, and I'm going to explain what it means in a way that will melt your brain. Imagine you have a sequence of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How would you describe this sequence in the shortest possible way? Easy. Numbers from 1 to 10, 7 words. You compress 10 numbers into 7 words. You found the pattern. Now imagine another sequence. 3, 1, 4, 1, 5, 9, 2, 6, 5, 3. How would you describe it? Well, you could just list the numbers. 3, 1, 4, 1, 5, 9, 2, 6, 5, 3. That's not compression, it's just repetition. But wait. These are the first 10 digits of pi. So you can say the first 10 digits of pi. 5 words. Compression again. But here's the question that breaks everything. What if the sequence is truly random? Completely, fundamentally, irreducibly random? Then there is no pattern, no shortcut, no compression possible. The shortest description of the sequence is the sequence itself. You cannot do better than simply listing every number. That is Kolmogorov complexity. It is the measure of the length of the shortest possible description of something. And for truly random things, for things without pattern, that complexity is maximal. You cannot reduce it. Now let's bring this back to AI. An AI, any AI, is essentially a compressor. It takes enormous amounts of training data and finds patterns. It compresses trillions of words, millions of images, into a set of weights and parameters. Those weights are the compression. They are the extracted pattern. When the AI generates text, it is decompressing. It is using the compressed patterns to produce new sequences that follow those same patterns. But here's the problem. If something has high Kolmogorov complexity, if it is truly random or irreducible, the AI cannot compress it. It cannot find a pattern because there is no pattern to find. And that means there are things an AI fundamentally cannot learn, no matter how much computational power you throw at it. No matter how many parameters you add, if the information is irreducibly complex, it is beyond reach. Let me give you a concrete example. True random numbers. If you ask an AI to generate random numbers, it will fail. It will generate numbers that look random, but have subtle patterns. Because the AI is a deterministic, pattern-based system. It cannot produce true randomness, because randomness is the absence of pattern. You could train an AI on billions of random sequences. It won't help, because every random sequence is unique, irreducible. There is no general pattern to learn. Now you might think, okay, but who cares about random numbers? That doesn't matter for real things. Wrong. Completely wrong. Because many things in the real world have high Kolmogorov complexity. Think about genuine creativity. I'm not talking about recombining existing things. I'm talking about creating something truly new, something that cannot be derived from previous patterns. That, by definition, has high Kolmogorov complexity. It cannot be compressed. It cannot be predicted. An AI can create variations. It can blend styles. It can interpolate between examples it has seen. But radical creativity, the kind of leap that Einstein made, that Picasso made, that Mozart made, requires generating something not in the training data and that cannot be extrapolated from existing patterns. And here's the part Feynman understood deeply. Physics itself has this property. Feynman worked on quantum electrodynamics. He was trying to calculate how particles interact, and he realized that some calculations are irreducibly complex. You cannot find a shortcut. You cannot simplify. You have to calculate every term, every interaction, every possibility. He called them calculations that cannot be done, not because we don't have fast enough computers, but because the complexity grows faster than any possible computer can keep up with. And this applies to AI in an even more fundamental way. An AI tries to predict, tries to anticipate, tries to find the next most likely word, the next most likely image. But if the system it is trying to model has high Kolmogorov complexity, if it is chaotic, if it is truly unpredictable, then there is no pattern to find. Think about the weather. We have incredible weather models, but we still cannot predict the weather accurately more than a few days ahead. Why? Because weather is a chaotic system. Small initial changes lead to huge differences later. Complexity explodes. You could train an AI on decades of weather data. You could give it every historical pattern, and it still couldn't accurately predict the weather a month from now. Not because it isn't smart enough, but because the very nature of the system resists compression. Now let's go deeper. Let's talk about consciousness. Many people believe that if we make an AI big enough, it will become conscious. It will have experiences. It will have a self. But if consciousness has high Kolmogorov complexity, if it is irreducible, then you cannot create it just by adding more patterns. Perhaps consciousness is not a pattern. Perhaps it is something that cannot be derived from training data. Feynman had a famous quote, "If you think you understand quantum mechanics, you don't understand quantum mechanics." Why? Because quantum mechanics is fundamentally counterintuitive. It does not compress into simple metaphors. The same may be true for consciousness. There may be no compressed description. You need to build the full system, not an approximation. And if that's the case, then AI will never be conscious in the human sense. Because AI is compression. It is pattern finding. Now let me be clear. This does not mean AI is useless. AI is incredibly powerful for everything that has patterns. Language? Full of patterns. AI excels. Image recognition? Visual patterns. AI dominates. Games with rules? AI beats humans easily. But there are things that resist patterns, and those will always remain beyond AI. True understanding versus memorization. An AI can memorize that water boils at 100 degrees. But does it understand why? Maybe not. Because deep understanding may be irreducible. Moral judgment in truly novel situations. You can train an AI on millions of ethical decisions. But when it encounters something it has never seen, how does it decide? It can't. Because genuine moral judgment may require values, experience, context that cannot be compressed. Here's another example Feynman loved: Heisenberg's uncertainty principle. You cannot know both the position and momentum of a particle with arbitrary precision simultaneously. This is not a technological limitation, it is a fundamental limitation of nature. The information does not exist to be known. The same may be true for AI. There may be questions where the required information is irreducibly complex, where there is no shortcut, and no AI can process the entire universe. This is called incomputability. It has been mathematically proven. There are problems that cannot be solved by any computer, no matter how much time you give it. The halting problem is the most famous classic example. Given any computer program, can you determine whether it will eventually halt or run forever? The answer is no. It is mathematically impossible, not difficult. Not that we haven't discovered the algorithm yet. Fundamentally impossible. And if there are incomputable things, then there are things AI cannot do. Not because it isn't intelligent enough, but because mathematical logic itself forbids it. Feynman understood this deeply. He knew there are limits to what we can know, limits to what we can compute, limits to what we can compress, and he embraced it. He didn't see it as a flaw. He saw it as a fundamental feature of reality. Nature is not obliged to be comprehensible to us. It is not obliged to compress itself into our theories. And when it resists, when it reveals itself as irreducible, that is not a problem. It is simply how things are. So here is the devastating conclusion. AI has a limit, an absolute, fundamental, mathematical limit. This limit is not hardware, not software, not data. It is the very structure of computation, of compression, of information itself. There are things that are irreducibly complex, things without patterns, things that cannot be compressed. And those things, by definition, lie beyond what any AI can learn or do. Radical creativity, deep understanding, consciousness, judgment in truly novel situations. These may be phenomena of high Kolmogorov complexity. They may be irreducible. And if they are, then no matter how many billions you invest, no matter how many petabytes of data you collect, no matter how many trillions of parameters you add, you will never cross that limit. Because the limit is not in the machine, it is in the nature of information itself. This is not pessimism. This is realism. This is intellectual honesty. This is the kind of clear, straightforward thinking that Feynman championed. We can make AI incredibly useful. We can solve huge problems. We can automate complex tasks. But we will not create a general superintelligence that thinks better than humans in every dimension. Because there are dimensions where human thought accesses something that pattern-based compression cannot reach, where we make leaps that are not in the data, where we genuinely create something new. And that something new may be exactly the part with high Kolmogorov complexity, the irreducible part, the part that resists AI. Feynman had another famous line: "Nature uses only the longest threads to weave her patterns, so that each small piece of her fabric reveals the organization of the entire tapestry." But what if some threads have no pattern? What if some parts of the fabric are truly random, truly unique? Then you cannot infer the whole from the part. You have to see everything. You have to process everything. There is no shortcut, and that is the limit of AI. There can be no shortcut where there is no pattern. There can be no compression where there is irreducibility. There can be no learning where there is true novelty. That is the limit, absolute, fundamental, mathematical.